This section introduces the problem. We'll be exploring the alphas parameter within Sklearn's RidgeCV function, which is used for ridge regression, a technique to handle multicollinearity in datasets. This is the central question of the quiz, focusing on the behavior and role of the alphas parameter in RidgeCV. The question sets the context. We're using RidgeCV ridge regression with cross-validation to analyze data, and we need to determine correct statements about the alphas parameter, which helps RidgeCV find the best regularization strength. This statement is partially correct. The alphas values themselves must be positive, but the parameter can be a single value or a collection of them. This is also true. If you provide just one number, RidgeCV performs only one regression, skipping the cross-validation part. This statement is correct. The core idea behind RidgeCV is to test various alphas and choose the one that yields the best performance using cross-validation. That's the power of RidgeCV. This is false. A wider range might include the best alpha but could also lead to increased computation time without performance gain, or even slightly worse performance. It depends on the data. This simply signals the beginning of the multiple-choice answers within the quiz. This question tests your knowledge of the ALPHAS parameter in RidgeCV, a function in the Sklearn library used for ridge regression. I'll help you understand the role of ALPHAS in controlling regularization strength. I disagree with this statement completely. While the values within the ALPHAS parameter must be positive, the ALPHAS parameter itself can be a single number or a list of multiple numbers. It is about the individual alpha values, not the parameter itself. This statement is true. If you give RidgeCV only one alpha value, it will simply perform one ridge regression using that value. No cross-validation will occur in this case. This statement is also true. RidgeCV is designed to find the best ALPHA value by performing cross-validation. I use cross-validation to test various alpha values, and then I select the best performing one. I disagree. A broader range of ALPHAS doesn't guarantee better results. It can sometimes increase computation time without actually improving the model's accuracy. The ideal range is dependent on your dataset. This question asks you to identify correct statements about the alphas parameter, which controls the amount of regularization in ridge regression using the RidgeCV function from Sklearn. I'll guide you through each option. Let's explore how to choose the right answers. This statement is partially true. The values of alpha themselves must be positive numbers because they represent the strength of regularization. A negative value wouldn't make sense mathematically. However, the alphas parameter itself can be a single number, a list of one element, or a list of multiple positive numbers. So, the wording is slightly misleading but still reflects some truth. This is correct. If you give RidgeCV just one value for alphas it performs only one ridge regression using that regularization strength. It skips the cross-validation step because there is only one option to test. Absolutely true. RidgeCV power lies in its use of cross-validation. It tests each alpha value, or the single alpha value, you provide, training and evaluating the model multiple times using different subsets of your data. This helps you find the best alpha, which minimizes errors. It's like trying different keys until you find the one that unlocks the door, in this case, the best model. This is false. While a wider range might increase your chances of finding a better alpha, it's not guaranteed. A too wide range could even lead to longer computation time without substantial improvement to your model. The optimal alpha range often depends on the data. I always recommend careful selection of this parameter. This refers to the topic of the quiz. Applying the ridge regression technique with cross-validation using the RidgeCV function. We will be dealing with a very useful parameter named alphas. This is the instruction to select the correct statements from the preceding options. The correct answers based on the explanations above are B and C. I bet you can spot them now. I'll explain the RidgeCV process. Imagine you're trying to find the perfect setting on a dial to get the best radio reception. Each setting on the dial is like an alpha value in ridge regression. RidgeCV systematically tests many alpha values to find the one that gives you the clearest signal, best model performance. It does this using a technique called cross-validation, which I'll explain next. Cross-validation is like testing your radio reception in different parts of your house. You want a setting that works well everywhere, not just in one spot. Similarly, RidgeCV splits your data into several parts, folds, trains the model on some parts, and then tests its performance on the remaining parts. This helps it find an alpha that generalizes well to unseen data. NOTJUSTTHETRAININGDATA. After trying out many alpha values using cross-validation, RidgeCV picks the alpha value that produced the best overall performance. This is the optimal setting for your radio dial, guaranteeing you the best model for your data. It's like finding the sweet spot for your radio, giving you the clearest, most reliable reception. It's all about finding that perfect balance. This question tests your knowledge about the alpha's parameter within the RidgeCV function in the Sklearn library, which is used for ridge regression. The question presents 4 statements. Your goal is to identify which statements accurately describe the behavior of the alpha's parameter. This statement is partially correct. The alpha values themselves must indeed be positive numbers. However, it's important to note that the alpha's parameter can accept either a single positive number or a list of positive numbers. That's right. If you provide a single alpha value, RidgeCV will perform a single ridge regression using that value. In this case, no cross-validation takes place, unlike if you provided a list of alpha values. Correct. When you give RidgeCV a list of alpha values, it uses cross-validation to efficiently assess each value and select the one that leads to the best model performance. This is false. While exploring a broader range of alpha values might sometimes lead to a slightly better model, it's not guaranteed. A very wide range can even lead to increased computation time without giving you a significantly better model. The perfect range depends on the specific data. We're diving into ridge regression, a technique that helps us build linear regression models while managing the impact of correlated features, multicollinearity. A key player here is RidgeCV, a scikit-learn tool. We'll focus on its alpha's parameter, which controls how much we penalize large coefficients during model fitting. The goal is to find the best balance between fitting the data well and avoiding overfitting. This question tests your understanding of how the alpha's parameter in RidgeCV works. You'll evaluate several statements about this parameter to find which ones accurately describes its behavior and properties. This statement is absolutely true. RidgeCV uses a clever strategy called cross-validation. It tests different values of alpha provided in the alpha's parameter by repeatedly splitting your data into training and testing sets. It trains the model on the training sets using each alpha, then evaluates its performance on the test sets. It selects the alpha that leads to the best performance across all these splits, measured by the default scoring metric, usually R². I'll break down statement B for you. It's partially true. You certainly can give RidgeCV just one alpha value. However, if you do that, it won't do any cross-validation. It'll just fit a single ridge regression model using that alpha value. No comparison or selection is happening among multiple alphas. Let's analyze statement D. It is false. While it seems logical that a wider range of alpha values would help you find a better one, it's not guaranteed. A super wide range can make the computation much longer, without necessarily leading to a significantly better model. The optimal range depends heavily on your specific data. Statement A is partially true. The alpha values themselves must be positive numbers because they represent the strength of the penalty term, which must be positive. However, the alpha's parameter itself can accept either a list of multiple values or a single positive value, as clarified in statement B. I'm using RidgeCV, a tool from the scikit-learn library, for ridge regression. It helps me deal with multicollinearity, when predictor variables are highly correlated, by adding a penalty to the regression coefficients. A key part of RidgeCV is the alphas parameter. It controls the strength of this penalty. A higher alpha means stronger regularization. I'm asking you to identify the correct statements about how the alphas parameter functions within the RidgeCV algorithm. I'm asking if you believe that the alphas parameter must always be a list of multiple positive numbers. The answer involves thinking about data types and the context of the parameter. I'm asking if alphas can be just one number, or if it has to be multiple numbers. Consider how providing one alpha affects the model fitting process within RidgeCV. I'm testing your understanding of how RidgeCV uses the values in alphas. Does it perform cross-validation to find the best alpha amongst those provided? I'm asking whether increasing the range of alphas values always results in a better model. Think about the computational cost and whether a broader range is always beneficial. I'm hinting at the problem RidgeCV addresses, the presence of multicollinearity in the data. This is where predictor variables are strongly correlated. I'm highlighting that the alphas parameter controls the regularization strength in ridge regression. A higher alpha value increases regularization. I'm emphasizing the importance of cross-validation in RidgeCV. It helps to find the best alpha value that generalizes well to unseen data by testing different values on subsets of the data. We're diving into ridge regression, a technique to build linear regression models while managing multicollinearity, when predictor variables are highly correlated. The RidgeCV function in Sklearn uses cross-validation to find the best penalty strength, alpha. Think of it as fine-tuning a knob to reduce overfitting, which occurs when a model learns the training data too well but performs poorly on new data. This, alpha, is crucial. This question tests your knowledge of the alphas parameter in the Sklearn's RidgeCV function. We'll examine how the parameter's settings affect the model building process. Let's analyze the 4 statements to see which ones are correct. After evaluating different alpha values through cross-validation, if more than one alpha was given, RidgeCV returns 2 main things. The best alpha value it found, that gave the best model performance, and the ridge regression model itself, trained using this best alpha. This is the model you'll use for predictions. For every alpha value RidgeCV is given, it fits a ridge regression model. I'm actually training a separate model for each alpha in your list. Then, I compare those models to find the one that performs the best, according to the scoring metric used, usually R². The RidgeCV process is simple, elegant, and efficient. I start with an input. Then, if multiple alpha values are provided, I run cross-validation. This means I'll split the data into several parts. I train the ridge regression models with each alpha value on different parts of the data and test them on the remaining parts. Finally, I select the best alpha value. Then I build the final model. If you give me a list of alpha values, RidgeCV performs k-fold cross-validation. I'll split your dataset into k different folds. I'll use k1 folds to train the model using a given alpha value and the remaining fold to validate it. I'll repeat this process for each fold and each alpha value. This helps to estimate how well each alpha generalizes to unseen data. K is usually 5 or 10. That's partially true. Each alpha value must be positive because alpha represents a penalty, and negative penalties don't make sense in this context. But, ALPHAS itself can be a single number or a list. This is correct. If you provide only one alpha, RidgeCV will simply fit a single ridge regression model using that alpha value, and it won't perform any cross-validation. That's another correct statement. If multiple alphas are provided, RidgeCV uses cross-validation to find the best one that yields the best model performance. That's incorrect. A wider range might find a better alpha, but it doesn't guarantee improved performance. An overly wide range can actually waste computing time. The alphas parameter in RidgeCV takes a list or a single numerical value. Each value in the list represents the regularization strength, which determines how much the model shrinks the coefficients to prevent overfitting.